guys. Today we will be going to discuss about the nomenclature of the fatty acids and their classification. So, as you uh, in the last semester you have seen some of the courses about the fats and oil. We will be briefly discussing about in the coming lecture. We will be going to briefly discuss all about that topics. So today we will be talking about the nomenclature of fatty acids and their classification. So let's start with this one. As you know that the fatty acids that is as you know that the fatty acid, these are the organic acids uh, normally contain of chain of the alkyl groups, and these chains that may contain variable carbon atoms that may range between 4 to 22, and the terminal is the carboxyl group COOH. So basic building units of the lipids, these are the fatty acids along with the cholesterol molecules. So there are so many type of the fatty acid. There are hundreds type of the fatty acids that occurs naturally, but the dominant is up to the C22, C24. So 90% of the fatty acid in our body occur in the form of esters of the triglycerides, glycolipids, phospholipids, and sphingolipids. And most of the fatty acids contain an even number of carbon atoms: C2, C4, C6, C8, C10, C12, C14, C16, C18, C20, C22, C24. So these are the even number of the carbon atoms. Fatty acids are also called as the carboxylic acid. As you know, the terminal is the carboxylic acid, presence of the carboxylic acid, COOH. And on the basis of presence of single or double bond, that may be classified as unsaturated or saturated type of the fatty acid. That will depend upon the presence of double bonds. So fatty acids are basically amphipathic in nature. It contains both the non-polar hydroxyl hydrocarbon chain and polar carboxyl groups, COOH. It's a polar. Therefore, act as the hydrophilic as well as the hydrophobic. So the chain length and the presence of the carboxylic acid that is giving the property, providing the property of hydrophilic as well as the hydrophobic in the same fatty acid molecule. There are three major categories of fatty acid: major fatty acids, minor fatty acids, uncommon fatty acids. Major fatty acids, these are present in the large quantities and that constitute for about 95% of the fatty acids present in most commonly used fats and oil. Minor fatty acids that occur as the secondary constituents of fats and oil. These are present as either homologous of major fatty acids or as isologous to them. Uncommon fatty acids are usually isolated from scarce sources, containing them as their major constituents. These are most commonly from the plant origin. So when we are going to classify the fatty acid. There are so many bases for this classification. We can classify it uh, about the chain length. We can classify it on body requirement. We can classify it on degree of unsaturation. We can classify it on position of hydrogen atoms. So we will be looking in the coming slides. So according to the chain length, we can classify it as the short chain fatty acid and the medium chain fatty acids. Short chain fatty acid that contain fatty acid with carbon atoms less than 6 and have lesser melting points. So short chain fatty acids are liquid at the room temperature due to its melting point. By the hydrolysis of the triglyceride, fatty acid produced gave a rancid butter flavor, for example, butyric acid. For medium chain fatty acids, that is 6 to 12 carbon atoms that comprise of 6 to 12 carbon atoms. For example, caproic acid, C6, caproilic acid, C8. And the long chain fatty acids that comprise of 14 to 20 carbon atoms. For example, myristic acid C14, palmitic acid C16, and there are some very long chain fatty acids that contain more than 22 carbon atoms in it. So these fatty acids that will have more higher melting points. These fatty acids cannot be metabolized by mitochondria. They are have to cut down shorter molecules into shorter molecules. They are normally metabolized in peroxisomes. These may be physiopathological harmful for human bodies, for example, the erucic acid, if taken in larger amounts. So, according to the body requirement, we can classify it into essential fatty acid and non-essential fatty acids. And the nutritionists, the people that are more interested in this kind of classification. Essential fatty acids are the fatty acids that are not generated by our body. These should be taken from the diet. For example, linoleic acid, linolenic acid, arachidonic acid that are required by the body but that cannot be synthesized by the human body. What are the non-essential fatty acids? That are the fatty acids that our body can generate. For example, palmitic acid, stearic acids. Now we will be talking about the classification based on the unsaturation. There are two classifications, saturated fatty acids and the unsaturated fatty acids. Saturated fatty acids containing all the single bonds that doesn't have the double bonds in their hydrocarbon chain. Normally these are tend to remain solid at room temperature. For example, butyric acid, caproic acid. Unsaturated fatty acids, on the other hand, that contain the double bond. Maybe there will be one double bond, maybe there will be two double bond, maybe there will be three double bond. So on the basis of, we can further classify that in the form of monounsaturated fatty acid containing only one double bond or polyunsaturated fatty acid PUFA containing more than one double bonds. Normally these are the liquid at the room temperature and found abundantly in fish and some vegetable oils. Examples are oleic acids. Classification of the fatty acid according to configuration of hydrogen atoms adjacent to the double bonds. So on the basis of this classification, we can classify the fatty acid into cis fatty acids and trans fatty acids. Cis fatty acids are the fatty acids in which adjacent hydrogen atoms are attached on the same side. So look at this one. In this, both these hydrogen that is on the same direction. This hydrogen and this hydrogen that is on the same orientation, same sides. So this is the cis fatty acid. This is a trans fatty acid. One hydrogen is on this side and other hydrogen is on opposite side. So this is a trans fatty acid. So trans fatty acids are the fatty acid in which hydrogen atoms are attached on opposite sides of the double bond. The chain with a significant number of trans fatty acids don't bend much and maintain the shape. And the trans fatty acid will have higher melting point as compared to cis type of the counterparts. So now let's talk about nomenclature of the fatty acids. So let's talk about the nomenclature of the fatty acids. There are so many type of the nomenclature available for the fatty acid in the literature. For example, delta nomenclatures, omega nomenclature, systematic nomenclature, telegraphic nomenclature, common names, trivial names. So delta nomenclatures, for delta nomenclature, there are three things we need to know. Total carbon atoms present in the fatty acids, total double bonds present in the fatty acids, and number of the carbon atoms, starting from the carboxylic acid end. So nomenclature, talking about the nomenclature, for example, look at this picture. This is the carboxylic end. This is the carboxylic end, COOH, you can see, and that contain carbon atoms C1, C2, C3, C4, C9, 10, 11, to then up to the 18, up to the 18 carbon atoms. And there is a double bond. All of them are the single bonds, but at the ninth and the 10th position, at the ninth and 10th carbon position, there is a double bond. This is the double bond. So it's a mono unsaturated fatty acid containing one double bond. How we can see, write this one, carbon 18C, C18 colon 1. That shows carbon chain length of 18 with one double bond, and this double bond exists at 9 carbon atom. So this is the way we can write this type of the nomenclature. So this molecule that consists of total 18 carbon atoms and one double bond. So number of carbon atoms from the carboxylic acid that will be counted, and the first double bond exists on number 9 position. So there is another nomenclature that is called as the omega nomenclature. In this type of the nomenclature, carbon atoms are counted from the methyl end, and the symbol of omega is used instead of delta. For example, for omega nomenclature, we need to know the three things. One is the total number of the carbon atoms, total number of the double bonds in the fatty acids, and number of carbon atoms are counted from methyl, and that is more important. So when we are doing the counting from the methyl end, we will see where the first double bond exists. So that is the basis for the omega nomenclature. So look at this one again. This is the example. So we are now counting. In the previous example, we started our counting from the carboxylic end. This is the carboxylic end. And this is the methyl end. This is the methyl end. So in this kind of the nomenclature, omega nomenclature, we are starting with methyl end. So this will be the first carbon. This is the methyl end. This will be the designated as the first carbon. This will be second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10, 11, 12, 13, 14, 15, 16, 17, and 18. And again, when we counting from here, the double bond exists at number 9 carbon atom. So we will call it as omega 9. This is the symbol for the omega, and this is called because the first double bond exists as 9th carbon atom. So we will call it omega 9 fatty acid. Omega 9 fatty acid. So how it will get written? 18, this molecule containing 18 carbon, this molecule containing one double bond, 18 1 omega 9. And as I told you earlier, that omega classification only, that is very useful for the nutritionist. Then another nomenclature is the systematic nomenclature. Systematic nomenclature, that is similar to the UPSC nomenclature, that make use of the OIC endings. For example, enoic, dienoic, trienoic. So that contain the OIC ending. This you can see, this is the OIC ending. So that contain the OIC ending. So enoic mean, in case of the unsaturated fatty acid, it's containing only the single double bond. Dienoic mean 2 double bonds. Trienoic mean 3 double bonds. For example, if the total number of carbon atom is 18 and it is saturated fatty acid, then the ending will be for the saturated fatty acid. I am again repeating the word saturated fatty acids. So in case of the saturated fatty acid, the ending will be anoic. In case of unsaturated fatty acid, enoic. Anoic and enoic. So if 18 carbon saturated fatty acid, that will be called octadecaenoic acid. If the total number of carbon atom is 18 and it is unsaturated fatty acids with one double bond, that will be called as octadecaenoic octadeca for 18, one double bond enoic acid. Enoic, this is the enoic. This is the enoic. Small mistake, spelling mistake. This is the enoic. Two double bonds, that will be called as octadeca enoic acid. Three double bonds, octadeca trienoic acid. If it is saturated, that is called octadeca enoic acid in case of the saturated. Then calligraphic nomenclature. For saturated fatty acids, we use the formula CNM. For naming, C means carbon, N means number of carbon atoms, and M means number of double bonds. So the different nomenclature that is being used for that purpose. For example, butyric acid, we use it as C40. It means that contains 4 carbon atoms and 0 double bonds. In case of the unsaturated fatty acids, we are using two methods, carboxylic and reference. In this, we start numbering from the carboxyl end and name of the fatty acid using the formula CNM, where C is the carbon, N is the number of carbon atoms, M is the number of double bonds. The position of the double bonds carbon atom starting from carboxyl, and you can see the carbon atom is counted from carboxyl. This is the first carbon, this is the second carbon, this is the third carbon, and so on. So another nomenclature method is the methyl end reference. In this method, we start numbering from the methyl end. Instead of using the carboxylic end, we are starting from the methyl end. So in the methyl, carbon is denoted by symbol Nr omega. We can use two symbols here, Nr omega. And the formula used for naming is CNM omega A, where C carbon and number of carbon atoms, M number of double bonds. Omega indicates that counting is started from the methyl end. So look at this one. When we start omega nomenclature, we starting from this methyl end. Omega 1, omega 2, omega 3. If double bond is there, it will be called as omega 3 fatty acids. The common names I have provided you in the class notes. You should memorize that. The common name of the fatty acids. These cannot be derived from the saturated structure of the fatty acids. There are some common names that are associated with the sources. For example, butyric acid, that is abundantly present in the butter, so its name is butyric acid. Oleic acid is derived from the aloe, olives, so that it is called as the oleic acid. So thanks